Alright, in this video we're going to solve this problem. Okay, the question says an aqueous solution of calcium chloride has the molarity and density of 0.55 molar and 1.15 grams per milliliters respectively. Calculate the mass percent, the mass volume percent, the molality, and the mole fraction. So we have the molarity given, so I'm just going to go ahead and write down whatever we are given. So we're starting out with the molarity, which is 0.55, and it's going to be the moles of calcium chloride. So the formula for the calcium chloride is going to be CaCl2 divided by 1 liters of the solution. In addition to that, this particular solution has the density of 1.15 grams of solution per milliliters of solution. So that's how you actually read the density. Now, based on those two given values, you have to go backward and figure out everything else. That's including the mass percent, mass volume percent, molality, and the mole fraction. Now, we're not really given any other information, including the volume, and that's sometimes it becomes challenging for students to kind of proceed from here since we don't have the volume. But let me ask you a question. If you have 100 milliliters of solution, or you have a 1000 milliliters of solution, whether you have 100 milliliters or 1000 milliliters, will they have a different densities or different molarities? The answer is no. Either whether you have 100 milliliters or 1000 milliliters, they both will have the same density and the same molarity. So it really doesn't matter if you start out with 100 milliliters or 1000 milliliters of solution. So to keep calculations simple, I like to start out with a 1000 milliliters of solution. 1000 milliliters of solution is going to be the same as 1 liters of solution. You want to make sure you can go back and forth from milliliters to the liters of solutions quickly. Okay, now let's start out with calculating the first one, which is the mass percent. And by definition, the mass percent is going to be the grams of the solute, which in this case is calcium chloride, divided by milliliters, sorry about that, divided by grams of solution, which is going to be times 100. Well, we don't know the grams of solution either. Okay, I don't have the value for the grams of calcium chloride, and neither I have the value for the grams of solution. However, what do we know is we are starting with 1000 milliliters of solutions. That's what we pretended that we're going to be using the solution to be 1000 milliliters. I can go ahead and calculate the grams of the solution since I know the density of the solution. The density of the solution is given to be 1.15, so I'll go and write down 1.15 grams of the solution per milliliters of solution. So when you set it up like that, the milliliters of solutions cancels out and you get your answers in grams of solution. So 1000 times 1.15 is going to give you 1150 grams of solution. Okay, well, what else do we need? We also need the grams of calcium chloride, and we do not have grams of calcium chloride. However, we do know we are using a 1 liters of solution, and we know the molarity. So work it backwards. Remember, the molarity is moles divided by liters, and molarity is given to be 0.55. Your moles is what we're trying to figure out, and in terms of liters, we are using 1 liters of solution, so it's going to be just 1 liter. So that's why I used actually 1 liters of solution or 1000 milliliters of solution, because it just makes the calculations a lot easier. So your actually moles of this calcium chloride is going to be 0.55 moles. Well, to solve the mass percent, you don't really need the moles, but rather you actually need the grams of calcium chloride. But will it be hard to figure out the grams of calcium chloride once you know the moles of calcium chloride? And the answer is it should not be. If you know the moles of calcium chloride, you should be able to figure out the grams of calcium chloride easily by using the molar mass. So I'll put down grams of calcium chloride on the top and divided by moles of calcium chloride on the bottom. So 1 mole, and the number on the top is going to be the molar mass, and the molar mass for the calcium chloride, so calcium is about 40, and then each of the chlorines is about 35.5, so that comes out to be 111 roughly grams of calcium chloride. So when you set it up like this, your moles of calcium chloride goes away, and now you can multiply 111 with 0.55, and that gives you the grams of calcium chloride. So that's going to be 61.05 grams of CaCl2. Alright, now we know the grams of calcium chloride and we know the grams of solution as well. So we should be able to figure out the mass percent. Alright, so your percent mass is going to be 61.05 grams of calcium chloride divided by the grams of solution, and we have calculated the grams of solutions to be 1150 grams of solution times 100. Okay, after doing this math, so you got 61.05 times 100 divided by 1150, and that comes out to be 5.31% CaCl2 by mass. Okay, so that takes care of one of the problems, which is the mass percent. Now if I go back, the second thing we have to calculate is the mass volume percent. So let's look at the mass volume percent now. The definition of your mass volume percent is going to be the mass of the solute, which in this case again is the calcium chloride, divided by the volume of the solution in milliliters. So milliliters of solution times 100. And I think now we know both of them. The mass of the solute came out to be 61.05 grams of CaCl2, and the milliliter solution, remember we started out with 1,000 milliliters of the solution in our problem. So divided by 1,000 milliliters of solution times 100, and let's see what that comes out to be. So we got 61.05 times 100 divided by 1,000. I mean, I should have just done that calculation in my mind, but it's fine. It comes out to be 6.11, roughly 6.11 percent CaCl2 by mass divided by volume. So that's how you want to look at it. Now, the mass percent and your volume percent, they are close to one another. The mass percent was 5.31% and your mass volume percent is 6.11%. They're usually close to one another, and they would be equal to one another if the solution is very dilute. But in this case, the solution is not very dilute and has a density over 1, so that's why they're not the same. Okay, the next concentration term that we have to figure out is the molality. The definition of molality is the moles of the solute, which is going to be the moles of CaCl2 divided by the kilograms of solvent. Okay, well, it seems like we do know the moles of calcium chloride. We actually calculated the moles of calcium chloride back here, which we said in 1,000 milliliters of solution or 1 liter of solutions, the moles of calcium chloride is going to be 0.55 moles. So we know that. What about grams of solvent? Okay, so let's focus on the grams of solvent. We know the total mass of our solution was 1150 grams of solution. All right, so it's 1150 grams of the solution minus the mass of solvent, the mass of the solute, which is the calcium chloride, is 61.05 grams of CaCl2. So when you subtract these two numbers, that will actually give you the mass of your solvents. So 1150 minus 61.05 comes out to be 1088.95 grams of your solvent, which in this case is going to be the water. That's because you are dealing with an aqueous solution. However, you do need the kilograms of the solvent. So now you do have the grams of the solvent. So to figure out the kilograms of solvent, I would start out with 1088.95 grams of water, and I'm trying to figure out the kilograms of water, so I'll put the kilograms of the water on the top, and since I'm trying to get rid of grams of water, I'll put that in the denominator. And now let's plug in the numbers. Remember the conversion factor between the kilograms and the grams. Kilo is just thousands, so it's going to be 1 kilograms equals to 1,000 grams. So that comes out to be 1.089. Let's just say that because that's just too many decimals after the period there. So that's going to be kilograms of water. Okay, well, we know both the moles of the calcium chloride and the kilograms of the solvent. So we can go ahead and calculate the molality now. So the molality is going to be 0.55 moles of CaCl2 divided by 1.089 kilograms of the water. So when we do this math, so 0.55 divided by 1.089 comes out to be 0.51 mole. So it's going to be a lowercase m. Okay, so the molarity of this solution was actually 0.55 molar. So the molality comes out to be 0.51 molar. So they're actually close to one another, but they're not exactly the same, and that's how they should be if the solution is not dilute enough. Okay, the last concentration term that we had to figure out is the mole fractions. So let's see, I'm trying to figure out the mole fraction of calcium chloride. So that would have been moles of calcium chloride divided by moles of calcium chloride plus moles of the water. And we already have the moles of calcium chloride. Okay, that was 0.55. However, we don't know the moles of the water. Okay, so this term right there is going to be 0.55 moles. We already know that. We don't know the moles of the water. However, we do know that we are having 1088.95 grams of water. So at this point, if you write down just 1089 grams of water, that's going to be completely okay. This 0.95 may not make a big difference at all. So if you know the grams of water, you can easily calculate the moles of water. So it's going to be 1089 grams of water. And we're trying to find the moles, so I'll put moles of water on the top, and we're trying to get rid of grams of water, so I'll have in the denominator And remember, the molar mass of the water is going to be 18.01. So if you don't have the molar mass of water handy, just go ahead and add up the atomic masses of hydrogen and the oxygen. So it's going to be 1089 divided by 18.01, and that comes out to be 60.47 moles of water. Okay, well, now we know both the moles of the calcium chloride and moles of the water, so it should be easy to figure out the mole fraction of calcium chloride. So the mole fraction of calcium chloride is going to be 0.55 moles divided by 0.55 plus 60.47. So in the denominator, you always want to have the total moles. So 0.55 divided by 0.55 plus 60.47 is will give you 0.009. So this doesn't really have any units because it's just the fractions of the moles of one of the compounds divided by the total moles. So it's not going to have any units. So it's going to be 0.009. And if the question does ask you to figure out the mole fraction of water, you can just subtract it, because since there's only two types of materials in this solution, the water and the calcium chloride, you can just subtract this 0.009 from 1, and that will give you the mole fraction of the water. So that's going to be 0.991. So that's just going to be, again, just a number or just a fraction, and it does not going to have any units. All right, so hope that helps, and I'll post some more questions soon.